Thank you for joining the Best Center on a tour of the Building Automation and HVAC/R Instructional Lab at College of DuPage in Glen Ellen, Illinois, which is 25 miles west of Chicago. The college serves over 28,000 students annually. Their HVAC/R program has multiple tracks in HVAC/R and facility maintenance. A Building Automation certificate is coming soon. Let's begin the tour of the 13,000 square foot lab.
Hi, my name is Bob Clark. I'm from the College of DuPage in Glen Ellen, Illinois. I'm the HVAC/R coordinator and also the facility management coordinator. And I'm responsible for making sure that every single piece of equipment that you see throughout this tour is brought here, procured, purchased, and installed properly like a professional. So, let us begin. And as you can see here to the right, you can see our lab from a bird's eye perspective. But our classrooms, as you can see, are clearly a considerable distance away from our actual lab. One of the things that we've been working towards is trying to pick up every energy source that we possibly could and bring all that information and those data points and trends back into our automation system. So our main lab gas valve that's coming in, we have our own gas meter on it with a bypass system so we can service it if need be. And that's monitoring all of the cubic feet of gas that's coming into our lab as we actually experience any type of learning down there. And then as you'll see as we turn around this classroom ahead of us, you'll see these classrooms all have access and control that's going down to each of the classrooms. So we can go straight into our projection system and we can demonstrate our building automation system right from here. We'll be setting up some different points. We'll be wiring some components up, wiring sensors directly into this controller, pulling it into our automation system, and we're going to take it and make it actually switch across 4 different pieces of equipment. So it's going to run through an ArcNet, it's going to run across an ArcNet communication, and then it's going to hit a BACnet over IP communication, and it's going to go back to an ArcNet, come back through that IP network, and then back out ArcNet, and we're going to get to see the communication all happen at once, like you would see in a building. So what we have here is, we have 7 trainers, if you count the front. We have 7 ALC trainers that can get students into understanding the networking concepts, the communication protocols between a variety of devices for one particular organization. This is automated logic. And with that being said, we input sensors, we input different thermostats, we input different ZN sensors. So students get an understanding of how to communicate across different systems. And when you start looking at these lines that run up, we have 4 poles of 2-wire shielded for communication wires, and we also have a Cat6 line that interconnects our lab with everything that you see in this classroom to all of our equipment that actually is down in the lab. So one of the concepts is how do you take a building and shrink that building into a lab? And considering we have 13,000 square feet, we said, okay, well, how are we going to do this? Well, our main focus was, well, we have to have something to control it. We have to exhibit the same conditions that you would see in a building. So we have to size the loads so that we can stress our systems and exhibit the same conditions that a building on a hot day would have to understand, or a cold day would have to understand. So we're first starting with our central cooling plant, as we would call it, and we decided, you know, looking at the price and how much things cost, we decided over here to build our own. So we decided to get our own bundles and build our own chillers. We want to make sure people understand balancing valves, differential pressure. We want everything to have temperature sensors and pressure sensors. So you notice going in, you see pressure sensors. On the tops are temperature sensors. All this stuff is going to get tied back into the automation system that's going to help us monitor and control for educational purposes. We're over-sensoring. Why? It's because we can. We're installing it ourselves. We're not paying contractors. When you see these pictures of our lab, contractors do not come in here, they do not turn one wrench. Our students build our lab. You start in our base level intro to safety classes, learning how to pipe fit, how to dimension pipe so we can cut it and make it look as nice as it actually looks, how to thread it, you know, just cutting pipe and threading pipe and dimensioning pipe are huge feats in our business, and is a crucial aspect of building any type of central plant like this for your students. So you have to have a foundation. Well, this equipment being controlled by our controls class, looking at the basic controls, how do these controls tie into our building automation system? What does the building automation do? How is energy consumed by each of these pieces of equipment? And how is this equipment supposed to be running? So anything from our refrigeration principles class that would understand compressors, chill water systems, or basically, as we would all call it, the vapor compression cycle, students get a chance to start digesting this from day one. What is this? They walk in, it's a showpiece in front of them all. They get to see what is happening here. We have pumps on bases that the students poured. They poured all these bases, they grouted all these bases, they put all the different accessories on top of this equipment. So you have, you know, triple duty valves from Bell and Gossets. You have, like I said, basket strainers. We have our temperature sensors on our suction side, our discharge side. So we have pressure taps on everything, and we have 2 more gauges coming where we can look at the differential pressure across all of our pumps. And most importantly, which most people don't pay attention to, is we have water care. So when we talk about the concept of building automation and the learning outcomes we need, building automation systems run central cooling plants. If you don't have a central cooling plant to run, you can teach the concepts, but why not teach how a system acts and reacts in a building automation system environment? So now you can set up, commission, and control and integrate a building automation system into your facilities, in your lab environment. Moving on here, our water care systems part of both our central heating and cooling plants class. So we'll have an automatic feed system, but it's a big component of running and operating a central plant. A lot of people miss out on water care concepts, and it's probably one of the most critical parts of every central heating and cooling plant. And these are the plants that the building automation systems run. You can have the greatest control system in the world, but if you don't have a system integrity and you're letting the water destroy everything, your automation system can't do anything about that. So our boiler system here, we just put a bunch of switches in, and we built this to mess with the students. So each one of these switches, it's reacting as zone valves. It's both a primary and it's a primary secondary system, but it can be just a primary system too. And it's set up with both direct and reverse return concepts. We basically built all of this stuff here to mess with the students and exhibit different running conditions. So if you put expansion tanks in the wrong area, what happens to your system? We have a variable speed drive that actually will be putting on our main pump here. We have a variable speed drive we'll put on the main pump here, and system curves. You can watch the pump curve shift, and students have to come in and balance each one of these systems, put the whole system together how we want, and then evaluate and land their pump curves, and then we can switch it into reverse return and change every different characteristic. So they really get to understand flow, they really get to understand balancing. And when you consider every building in America and realize that water and balancing and flow is what every commercial building in America is using, and every major facility, you really have to sit back and think how important hydronic training is for any type of high performance building technician or a service technician. When I go looking at these systems, we have radiant heat moving up in the world now. So we have all the different balancing manifolds for radiant heating, so we can balance them. We can shift them into both direct and reverse return. In this situation, we have everything decoupled on a secondary loop. But we have a thermostatic expansion valve, thermostatic mixing valve, like you would see in any type of driveway or snow melt application. We kind of wanted to get the tubes out so students would see how we could actually land them. But we're actually planning on pouring a piece of concrete and maybe do a cutaway and show how this actually heats a slab scenario, which is important. But each one of these systems is a primary, secondary system that, you know, with the flip of two valves, I can throw this from direct to reverse return, and it changes all the flow characteristics. A lot of people like reverse return because it's almost like a self-balancing type situation. The problem is that it doesn't really self-balance. So you still have to manage your flow. But in this scenario here, we have risers that go up, and you can balance the risers as they move up. And as they move up, the scenario gets a little bit more difficult to solve. So we wanted to build bays of scenarios that students could get to understand, whereas you see unit heaters like this on, well, actually you see them in our building sitting right up there. So they're in every building or warehouse in the country. We pump water to them, we blow air across them. How the electrical systems integrate with them is very important. Is very important. We also wanted to have a pump test in place, so we could see how pumps tested against each other, how flow would be restricted. I don't know if you can get the camera in here to see, but if you look in here, you can start to see these old flow meters. You can see how they can pump against each other and slow each other down. Even if it's wide open, I mean, this pump's not doing much anything. So they all are pressurizing against each other too. So you get to see how different pumps actually perform in a scenario. We also have a couple of different decoupling techniques that you would see in the water world. But for the most part, it's a great hydronic training resource. It's a great way to understand the system. And if you can digest just the valving on these systems and how it operates, you're miles ahead of the game when you get out into the working world, because you understand the most important thing in the world. When you see something that's complicated, stop and break it down, and don't start turning valves until you actually understand what you're doing. So the rooftops that we see here as we line up down this row here, we'll have our automation controllers tapping into all of the economizers that we have in them, and they'll also have the capability of starting up each and every one of these units. One of the concepts that we try to disillusion, I would say, students from the complexity of these machines is, so we have them this semester, we just started taking the rooftops. Each of these were cut down to the frame. So we cut out every single piece down to the actual frame that lays on top of that wood right there. They cut out every single piece, pulled every piece of wire out, and then they had to reassemble the entire unit. And as you see, they put it back together and they're all operating. They're also changing the oil on our compressors, which you don't see a lot in a lot of refrigeration. A lot of people like to just replace them, but it gets them conscious of oil. And in the refrigeration business, for our commercial air conditioning class, very important to understand oil, because oil destroys efficiency. No oil destroys compressors. I always tell the students, you wouldn't drive around town with your oil plug open, would you? You know, your car wouldn't make it very far. It's the same concept in refrigeration. You don't want to sit there and wash your oil into other parts of the system so it can't do its job. In our facility maintenance mechanic program, we have mechanical maintenance classes, so we had to build our own. If you want to get a shot at this, we're putting together with our machine shop, upgrading and moving out other things. We got a lathe, and we'll have a mill, and basically more or less our own maintenance shop. So we need a place to work. Obviously, you see the type of equipment and the intensity of equipment. It's pretty important to have. I mean, when you start to think about all the pipe fitting that has to happen and all the fittings that you need when you're working on a system like this, it's unbelievable how many pieces of pipe have to be screwed together in order to make a system come together. This is an air handler that was special ordered through Trane, and it was, you know, an inspiration from the Best Center 2 when we went down to Kelly. I like to call it Kelly, not Keeley, Kelly. But when we went down to Kelly, I enjoyed their commercial air handler, and you know, I was always thinking about one, but it inspired me to write for a grant, and I got a Resource for Excellence grant, which is an internal grant at the College of DuPage, and it allowed me to purchase this and some other things to get this whole central plant idea and concept moving. And it evolved into our building our own chillers, and it's evolved into staging our own boilers, and it's evolved into, you know, buying our own steam boilers. So we have every type of system here that you can possibly imagine. This system, the ductwork that you see with this system is all built by our students. This is a secondary system. If you can see, this is a secondary system where they can monitor temperature and pressure drop across each one of these circuits. We're going to be able to see everything with our BAS system. We're going to be able to see all the points that are involved with just this air handler alone. We'll be able to speed it up, slow it down. There's a variable speed drive right in here on top of it. And we're actually going to mock an outdoor air system. Once all the piping's complete and we get the heating circuit in, we're going to build in an outdoor air simulator too, so we'll be able to cool or heat the air on a secondary purpose to drag it in to show what happens in low ambient type environments. So it'll be interesting to watch how things perform as we move forward. But these air handlers are pretty fascinating. I don't know if you can get a shot in there with the coils, but we're going to be able to look at static pressures and drop. We'll have VAVs we're going to tie into this once we have a diverter to move our ductwork the other way. But again, we built all this ductwork, and we like doing our own stuff here because I think that's what grants our program merit with our, you know, our industry advisory board. This will be used in system balancing. This will be used in our commercial air conditioning class. It'll be used in our central cooling plants, central heating plants. This is a major load. This is the brunt of the load. I'm going to split the rest of the load across about 4 different air systems. But this will take the most of it, and this is where we can really get into intricate control. So this is an air handler that's no different, exactly how this is set up. This is no different than what you would see in our air handling rooms in this actual building. So every piece that's in here is going to be controlled that same type of way. So we're going to have a micro-sized air handler that is exactly built pretty much exactly the same as you would see in a major facility. It's just smaller. Again, a micro-sized building to see how things react so that we can play with the dynamics, the changing dynamics in all these systems, and actually take the time to study and understand how energy is affected and to really drive home that energy concept of how to operate, maintain, and repair equipment as a profession. Another big one is that I try to stress in this program is water care. You know, water care and water. We don't move refrigerant in commercial buildings, we move water. The refrigerant just cools the water. So the most vital part and biggest energy sucker of every facility is the pump, like I was saying earlier. So we took these, we tore them all down. Now, what the students do each semester in our central cooling plants class is they have to pull everything apart. They pull everything down, they tear it down, and they take the whole bearing assembly apart, and they press it all apart, and they get to see every detail how it gets fitted together in a pump. So it brings the whole idea of centrifugal pumps, changing a pump seal, getting those concepts down to a whole new level. And they get that experience of rebuilding pumps, which is something that all people, everybody that hires somebody wants. Pumps run everything in our world, everything. So having a good grasp of pump systems, pump curves like I was talking about earlier, studying those curves, how they operate, vital to the success of effective energy management in our society. and it's something that they need to know. They also get to learn motor alignment, the number one cause of pump seal failure, the number one, cause of wasted energy, misalignment. So if you look over here, this meter that sits in the wall here is the same one that ComEd uses to analyze their power. It's a Nexus 1500 from Electro Industries. It is probably the top of the line meter in the entire country for taking a look at monitoring electricity for facility electrical systems. So what that's doing is it's communicating back to our automation system, and it's monitoring every piece of power that happens across our entire lab. So we are monitoring all energy coming into our lab, and we're monitoring not just electrical, but also gas, as you saw earlier. And we can start creating trends and data points and energy reports to understand how to go through this data and make good decisions about where things are possibly being wasted. In the real world, you can't learn like this. And the reason you can't is because you can't knock out facility systems that have to run in order to maintain the integrity of comfort in a building. Here, we have a micro-sized building that we can mess with, play with the controls, develop and create all kinds of different variables so that technicians can be faced with real troubleshooting techniques, and at the same time have to overcome them and maybe even just rework everything right from the beginning. So we can turn our systems off. We're not connected to our building. Whereas when you go on a job in any type of real building environment, what do you have to do? You're trying to get that thing going. You don't have time to learn how to get it running efficiently. You don't have time to consider energy. You don't have time to really tune it. You don't have time to even commission it maybe properly. But all these variables, everything from air distribution all the way to the impeller size on this pump matters. And if you can understand how this works, you really need to move forward.